for sure. The sky looks very nice, has all day long. It's now 8:40 in the evening. Sunset was around 7:04 at almost 45 degrees north latitude. You're looking at Messier 15. Thought I'd start off with that. I spent some time focusing, but we could lose a little bit as things cool off a little during the course of the evening. Resolution looks pretty good. We're filling the field at 100, well, almost 150x. That's our first view. I'm going to go ahead and set up the histogram to tighten things up a little bit. I'm trying to improve on the aesthetics, but I just do not want to miss some of those faint galaxies as well. What do you think about that? Okay, I'm going to start off at NGC 6800 tonight. All these studies should be culminating. I'd like to get some more views of planetary nebula, so I'm going to look especially for them on this evening because we are entering, because Aquila the eagle is culminating towards the south, and it is definitely a birthplace, or should I say, a graveyard of dying stars. So let's move on to NGC 6800 and get a sense of things and make our final adjustments, hopefully with 10-second exposure times to the histogram setting and get some decent views. Okay, there's a question that popped up in my mind, excuse me, the other evening, and that is, what is the faintest galaxies we'll tend to see at the 60x magnification, 20% e-zoom? And one of my answers to begin with is NGC 6900, which is a 14th magnitude galaxy. And if we're seeing it on the screen right now, which I do believe we are, then these histogram settings are pretty good for 10-second exposure times. NGC 6900 is a galaxy in Aquila. Now, in the Gemini 2, it's stated to be magnitude 14, 1 by 0.8 arcminutes, spiral with a lowercase b, twice removed, 230 million light years distant. If it is twice removed from lenticular, then its magnitude is probably something more like 13.2. But it's quite apparent on the screen, and with a little zoomage, either that's our galaxy or it's a planetary nebula. Wow, that looks more like a planetary. Let's go back down. I'm going to go ahead and continue zooming in on this planetary. No, it's got a bright core face on, and it is 1 by 0.8 arcminutes. This is our galaxy, but it sure did look like a planetary, and we are seeing it at, let's see, this should be 20% e-zoom. Yep, at 20% e-zoom or 60x. And I have the histogram set up for good views in the middle third of the sky. Okay, have a look at this field. There should be a galaxy here, listed as slightly brighter than the last one. NGC 6901 in Aquila, magnitude 13.7, 1.1 by 0.4 arcminute. Yep, it's there. Spiral with a bar, lowercase ab, 216 million light years distant. Typically, a capital B means that it has only 2 spiral arms. It's at right ascension 20 hours, 22 minutes, 21 seconds, and a declination of plus 6 degrees, 25 minutes, 47 seconds. Don't think I'm going to zoom because what we're really trying to do is find a threshold for these settings at 10-second exposure time. Okay, what do you think we're seeing here? Why, that's obviously a planetary nebula, and it's quite clear in the middle of the field, so the alignment is perfect at this particular point. Let's zoom in on it. That's our 60x view. If we go to 40%, it's our 120x view. 50% is our 150. Ooh, things are looking quite nice. This planetary is magnitude 12, 44 by 38 arc seconds. Got some nice coloration too, with a 14th magnitude central star, 5,700 light years distant, so it's more than twice the distance to the ring. The central star, as I said, is magnitude 14. We're at right ascension 20 hours, 22 minutes, 23 seconds. and a nice northerly declination of 20 degrees, 6 minutes, 16 seconds. Planetary nebulae usually can handle very high magnifications. So this is our 300x view. We're seeing all kinds of modeling. It's very nice. The stars are looking large, but fairly tight. So the focus is pretty good right now in Eddie, the F8 ED refractor. One of the things I would love to do with Eddie is to get a focal reducer, because I'd rather get back down to 150x as the go-to magnification, because even though the Newt is got an obstruction in it, it actually seems to give better views than the unobstructed 150, largely because you can operate at 150x and you're at 100% e-zoom, putting to use all of the pixels in the CCD imager. Okay, scan this image and see if you can find a galaxy, NGC 6917, in Delphinus. Magnitude 14.5, which could be erroneous, could be blue-violet. Spiral with peculiarities, 1.4 by 1 arc minutes, 214 million light years distant. Right ascension is 20 hours, 27 minutes, 28 seconds, with a declination of plus 8 degrees, 5 minutes, 51 seconds. And yes, I do believe the galaxy is to be seen right there. Let's run it up to the 150x view, not using all the pixels. Boy, it's a little bit offset, isn't it? And we'll go up to use all the pixels at 100% e-zoom. Now this is a 14.5 magnitude galaxy. We saw it from the outset at 10-second exposure times. I do believe 10-second exposure times are about the equivalent of a 45-inch scope at the eyepiece. I did the math on this yesterday, included it in a video, and the math is pretty solid. It's predicting some pretty good stuff. So I have some high confidence in it, although if anybody wants to check my reasoning or my mathematics, please feel free to do so. Okay, scan this real-time image for a galaxy in Delphinus, magnitude 14.5, 0.5 by 0.2 arc minutes, a lenticular spiral. It's pretty obvious to me there. 14.5, come on. 201 million light years distant. Right ascension is 20, 32, 38 with a declination of plus 9 degrees, 54 minutes, 58 seconds. Since it is an edge on, I want to really push this baby up. You can actually see the curl in the spiral arms here. Let's go ahead push it up to 100x so we can fully reveal it. There's another galaxy in the same field. These two are kind of sharing space and time. Well, I think we may have tracked down the neighboring galaxy. We're going to need to use magnification to turn it up. There it is. What a beautiful pair. Edge-on galaxies. Hey, that's not a bad view. Let's go to 100x and drop it down. Anyway, I'll give you the data on NGC 6927A, and I rather doubt this data, frankly. It's a galaxy in Delphinus, magnitude 16.5. 0.3 by 0.1 arc minutes. It's an elliptical 6 galaxy. That doesn't look like an elliptical 6. It looks like a spiral, so maybe it's wrong. 193 million light years distant, right ascension 20, 32, 36, and a declination very close to the last of plus 9 degrees, 52 minutes, and 58 seconds. We go back down to the good view right here at 150x. Very nice pair of slanted eyes looking at you. Okay, we've already established that at 10-second exposure time, we probably can pick out 14th magnitude galaxies. And here's an example, but there's one interesting aspect to it. It's pretty deep. It's down below the celestial equator, and Capricorn, as a matter of fact. NGC 6931, galaxy magnitude 14, 1 by 0.4 arc minute, spiral with a lowercase b. 154 million light years distant, right ascension 203341 with a declination of minus 11 degrees, 22 minutes, 8 seconds. It's pretty obvious if that's it in the field, giving us 1 by 0.4 aspect ratio. Here we go. Looking good. I'm going to go ahead and move on. We are seeing what are ostensibly 14th magnitude galaxies at 60x on this particularly good night of seeing. Okay, what we're seeing here is another globular cluster. This is NGC 6981, also known as Messier 72. I don't know how the last one was lost to Charles Messier and Machine. This one is fainter, magnitude 9.2, smaller, 5.9 arc minutes. Stars are even fainter, magnitude 14.2. It's a class 9, so even less dense than the previous one. 55,000 light years distant. Right ascension 20, 5327 with a declination of minus 12, 32, 14. Let's at least run it up for a 50. Ooh, boy. Look at the stars being distorted. Must be some motion on my part. Let me go ahead and pause and we'll try to get a stabilized version. Okay, here's a better view of NGC 6981, globular cluster in Aquarius, also known as Messier 72, magnitude 9.2, 5.9 arc minutes in size, magnitude 14.2 stars, brightest. Class 9, 55,000 light years distant with a right ascension of 205327 and a declination of minus 12, 32, 14. Don't know how the last globular cluster was missed. It was certainly more present than Messier 72. Somebody just in the 1750s, 60s just overlooked it. Okay, I thought we would have a view of the eastern veil. 30%, up to 90x view is basically it's sprawling across the field quite nicely. 10-second exposure time. That's a very nice view. Lots of texture. Supernova remnant in Cygnus, magnitude 760 by 8 arc minutes in size, 1,500 light years distant. Right ascension 205619 with a declination of plus 31 degrees, 44 minutes, 36 seconds. Very nice view. And we've had some very good ones before, even as long as 60-second exposure times, I do believe. What we're looking for here is the last study in the 6000 series. This is NGC 6999, and what got my attention is down in Microscopium Galaxy, magnitude 14, 0.9 by 0.7 arc minute, lenticular spiral, 466 million light years distant. Puts it at about the size of Messier 31. We're at RA 210159 with a declination of minus 28 degrees, 3 minutes, 33 seconds, about as deep as I ever want to go. Let's see if we can pick this one up. The background sky isn't so bad, is it? All right, so I could not make any claims to seeing this galaxy, but it is magnitude 14 and maybe magnitude 14. It's probably one of these little fuzzy spots, but who can tell this far south? Declination. Well, this baby is tiny, but I think you can figure out what it is. It's a globular cluster. It happens to be located in Delphinus. Center it up in the field. It's magnitude 10.6, pretty faint, although a galaxy at 10.6 would look as good. 2.8 arc minutes in size. The stars, which we are resolving, brightest ones are magnitude 15.6, so that's quite impressive. Takes at least, I believe, about a 15-inch scope to resolve stars, to even show stars down to magnitude 15.6. It is a class 1, which means very, very dense. 133,000 light years distant. That explains why it's so small and but reasonably bright actually at that distance. Right ascension is 210129 and declination is plus 16 degrees, 11 minutes, 14 seconds. That's probably our best magnified view at 70%. I would believe that's somewhere around 200x. What we're probably seeing here is an extremely bright planetary nebula. This is NGC 7009 in Aquarius. It has those annular, it looks, I guess it's called the Saturn planetary. It's magnitude 8.3, 28 by 23 arc seconds in size. The central star is magnitude 12.9, 4,300 light years distant. It's too bad we can't tease out some interior detail. Super luminous. Probably the only way to make sense of this planetary is to reduce our exposure time to about maybe 2 seconds. Let's give that a shot, because after all, we are interested in planetaries this evening. Here's our 2-second view, probably roughly an 18-inch view. We're seeing the extensions, the polar extensions of this, but we're still not making out a central star or much of the texture and nebulosity. Let's drop it down again. At 0.5 seconds, roughly a 10-inch scope, we're starting to resolve some of the texture, but we've lost the extensions that give it the Saturn-like quality. Try it one more time. We're going to lose the extensions, but I'd love to be able to turn up that central star. Let's drop down to 6-inch settings at 0.2 seconds. Well, here's a 600x view, and we're seeing some modeling, but who knows what that refers to. I'll drop it back down to 300. It does look like some modeling there. We're not seeing the extensions, and we're not seeing the central star. Sorry, folks, that just without the planetary nebula filter, it's just that we're not going to make out much with this overbright NGC 7009 planetary in Aquarius. Here we're having a rather brilliantly textured view of Messier 31. Wow, we're getting some fine detail in the dark lane that bisects it. Quite extraordinary, really. But you know what? I think we want to look at Messier 110 and possibly NGC 145 as well. So let me pause out on this. Okay, here's that view of Messier 110, satellite galaxy to Messier 31. Let's move on now to NGC 147, I believe. Well, quite present at 30 seconds, wouldn't you say? NGC 147, a galaxy in Cassiopeia, satellite of 31, magnitude 9.5, 13.5 by 8.2 arc minutes, gives it an average surface brightness of about 14.5. It's a disturbed elliptical, 2.4 million light years distant. Light ascension is just after 0 hour, 33 minutes, 11 seconds. Declination's a bit high. We may be getting somewhat of an obstruction, plus 48 degrees, 30 minutes, 27 seconds. Now, I do believe we have just completed a second pass. So what I'm going to do is pause and allow a third pass to manifest. And then we will end up Carpe docking out. Well, as it stands, we cannot find matched triangles, which means the stars aren't doubling. So that's one of the reasons why we can't have multiple stacks that actually reveal the galaxy more thoroughly. So with that observation and some 23 minutes into this video, of which I've got to cut out a couple of minutes because I allowed it to continue without pausing at certain points, I am going to say Carpe.